So today we're going to build a small mini game based on the lessons we've learned up until now, which means that there is probably many different ways to create a game like this, and I bet you that there is many more optimal ways of creating a game like this. But I really want to keep things within what we've learned up until now, so we don't deviate too far from the lessons. Like there will be some new things in here, but some things like, for example, creating static classes for game managers and stuff like that. That's not something we've talked about yet, so we're not gonna touch upon that in this episode here. We're just gonna sort of like focus on trying to keep within the lessons we've done so far. Oh, there's a bee in here. Get rid of it. So just to talk a bit about what exactly we're going to be building in this video here, we're going to build a small game where you have a tank in the middle of the screen that you can control with the keyboard, and then based on where the mouse is, it's going to aim and shoot that direction. And then we're going to have enemies that spawn around the screen in random locations that are actually going to chase after the tank, and if they touch you, you die and it's game over. So your goal is to shoot the enemies before they actually get to touch you. And then over time, the enemies are going to spawn a little bit faster, so it's going to get gradually more difficult until you at some point die. So just a very small basic mini game that is kind of fun to create and also teaches you how to actually do stuff with the mouse cursor on screen, which is something that I think is really cool because that is often, a lot of times games have something with mouses on screen where you need to figure out where on the screen the mouse cursor is. So that's something that you're going to learn today. So now to begin with, as you can see, I have absolutely nothing except for I actually set up my scene so that my game view was actually set to full HD, so we have 1920 by 1080. I did also create a couple of folders inside my assets folder, so I have a prefabs and I have a scripts folder, besides just the regular scenes folder that you have as a default. So you probably should create those two so you have them already. But besides that, everything else is just completely fresh. I haven't done anything, so what we're going to start with is we're going to create the actual player that we're going to be controlling inside the game. Now, you can do this in many types of ways. You could just go in and right click and just create a square because, we don't really need to do anything fancy here for the technical aspect to work. But let's spend just a little bit of time to make it into a tank. So we're going to create a square to start with here. I'm going to call this one player. Then I'm going to go inside my transform and reset it because that's important. I'm also going to change the color of it so we have something that is maybe like a blue. So we have a blue tank that is like running around like so. I'm also going to add a component so we have a rigid body 2D, since that is something that we usually always need to have whenever we want to use physics inside our game. So a rigid body 2D is definitely appreciated. We're going to set the collision detection to continuous and the interpolate to interpolate, since we don't want to accidentally face into any kind of walls or anything like that. And we also want to have smooth movement as we're actually playing the game. So changing these things are going to help with that. The next thing we're going to do is we're actually going to set the gravity scale to 0 because we don't want this game object to fall down, since it's kind of like the gravity is going in towards the screen, since it's like a top view down 2D game. So I'm going to set that to 0 so we don't actually fall down. And then I'm also going to add a box collider, since we also want to have some collision going on here. So box collider 2D. And everything is just like kind of what it's supposed to be here. The next thing I want to do is just kind of like make the tank look a little bit more like a tank. So we're going to go inside 2D object after right clicking on the player game object. I'm going to go into sprites and choose capsule. And I'm just going to like change this one so we have something that looks kind of like maybe like the wheels of a tank on the side of it. So we're going to position it just a little bit to the side. It is already pretty... we don't have to reset the transform because we actually created it within the player game object. So it is just going to have the transform as the parent object. So we don't have to like right click and reset. But we're going to go in here and I'm just going to set it to minus 0.5. And I'm going to scale it just a little bit so we don't have the x-axis being, just like super wide. I'm also going to, let's actually make that 0.5. I'm also going to change the height of it just so we have it somewhere down here. So maybe like 0.6. And then I'm just going to change the color of it to something a little bit darker than the blue that we chose already. So I'm just going to choose the eyedrop tool, pick the blue, and then just like make a little bit darker so we have some wheels that look like wheels, like so. Now we do want to make sure that we have the order in the layer correct so we don't accidentally have anything happening. So what I want to do here is I actually want to make sure that the order in the layer is going to be 10. on the wheels. And I want my player to have a order of 20, so it goes on top of it. And it's just kind of like nice to have the ordering proper so they don't go accidentally on top of each other inside the game. I'm going to duplicate this capsule by clicking Control D on the capsule, so we have a second one. And I'm just going to slide it over to plus 0.5. Now it's just going to keep the order in layer as it is right now with 10. And then I'm also going to right click my player and I'm going to create a spawn point. Well, more like the tip of the tank, where the bullet has to come out. So I'm going to go under 2D object, sprites, circle. And I'm just going to call this one something like bullet spawn, just so we have some naming. Bullet spawn. And I'm just going to set this one to have a order in layers set to something like 0 because it just needs to be at the bottom there. Now we do of course need to move this up a little bit so we don't have it sitting down there at the bottom of the tank. So we're just going to move it up. It's going to be 0.5. And we're also going to change the size of it so we have it a little bit smaller. So it's going to be around 0.3. And the same thing for the y-axis, 0.3. And I'm just going to go ahead and put a different color for it so we can actually make it maybe the same color as the wheels here. So we have something that kind of looks like a tank. I don't know if you can see this looks like a tank, but in my head, it kind of looks like a retro 80s, one of those arcade game tank type things that you have in the arcade machines. Now, the next thing we're going to create is something called a game manager. Now, a game manager, we can actually, inside a game, we have many different types of managers, but specifically the game manager kind of takes care of the overall flow of the game. So like stuff like game over, is a game over, it takes care of that. Might take care of the menu, so you're like selecting certain things, it takes care of like the overall things that controls the macro things of the game, so to speak. So what I'm going to do is I'm just going to just close down my player and I'm going to right click. I'm going to create a empty game object and I'm going to call this one Game Manager. Now the Game Manager is going to be moved to the top here, just so we have it maybe somewhere below the camera, just so we have a little bit of hierarchy. And just for order's sake, since I don't like looking at it, let's actually go ahead and reset the transform so it's set to 0. You won't actually be able to see it inside the scene because it's just kind of like a game object that is there, but it's not really visible inside the game because it just needs to take care of some rules about the game, like game over and that kind of thing. So it's just kind of like there in the background, doing its own thing. What I do want to do, however, is I want to go inside my scripts folder and I want to create a new script. So create C# script. And I want to call this one Game Manager. And something you'll notice once I click enter is that it's actually going to change its icon down here because the Game Manager is kind of like an essential thing that all the games that you create inside Unity have. Because it has to you have to have a script that takes care of like the flow of the game and just like the overall thing. So it's going to change this one just so you can see that, okay, this is the Game Manager script. So don't get like freaked out by changing icon. It's just so you know that this is the Game Manager script, okay? So I'm going to take this one and I'm going to drag it inside my Game Manager. And I'm also going to open it up so we can actually make changes to it. And then we're going to set up just a little bit of code, just a very little. Like I said, we haven't really discussed game managers and that type of thing yet. So let's keep this simple and just kind of like create a very basic game manager here. So the first thing I'm going to do is I'm going to delete the start and the update since we don't actually need to run anything like that inside the game manager. And instead, I'm going to create a public Boolean. And I'm going to call this one underscore game over. Now, game over is just basically going to tell our game that, okay, is the game over right now? And because it's set to false, it means that it's not game over yet. So once this becomes true, then a whole bunch of things changes inside our game because, we need the player to stop moving. We need the enemies to stop spawning in. The enemies that are already spawned in has to stop following the player. So a bunch of different things needs to happen once we hit game over, which is when this one becomes true. Currently, this is all we need to have inside this game manager. Like I said, you would typically do something else like making this into a singleton type class where you have like the class set to static, so you could just access it from anywhere and there wouldn't be like extra copies of this class. We're not going to get into that sort of area just quite yet. Just let's keep it like this. And let's go ahead and go back inside Unity. So the next thing we're going to create is just a basic player controller, so we can actually control this tank that we have inside our screen here, because we want to be able to, with the WASD keys, move it left and right, up and down, or maybe the arrow keys. And we also need to insert something so that my mouse is actually turning the tank and allows for you to actually shoot bullets in the direction of where you're aiming at. So what I'm going to do is I'm going to go inside my scripts folder again, right click, I'm going to create a C# script, and I'm going to call this one player controller, because this one takes care of controlling our player. There we go. Let's actually go and open that up. Now, there's a couple of things we need to do inside our player controller. The first thing is that we do actually need to create a couple of fields. The first one is going to be the one we actually grab the game manager, because we need to be able to tell if the game is game over or not, because then we need to disable the player and do all sorts of things. So what I'm going to do is I'm going to say we want to have a game manager type game object, and I'm going to set this one to _GameManager. Now, we haven't actually grabbed the game manager yet. We're going to do that once we get into the start method, so we're just going to wait with that. The next thing we're going to add in is going to be our rigid body, because we do have physics on the player and we need to be able to move our player using physics inside our code. So that's going to be very important. Now, something to mention here that is very important to mention is that whenever you do anything using physics on, for example, a player, you need to make sure that everything about the player when it comes to movement is physics-based. Because if you don't do that, then you can have some, like non-physics movement and physics movement kind of like go against each other and it starts fighting each other. And then you get this like jittery effect on your game objects inside the game. So it's very important that whenever you do anything, like don't have movement that are physics-based and non-physics-based, like, go on top of each other inside your code. And the same thing goes for like rotations. If you have a rotation that's physics-based and then you have like a knockback effect or something that is not physics-based, then it can fight each other. So it's very important you don't do that, okay? Just a quick note about the rigid body whenever you create a game and stuff like that. So with that said, the next thing we're going to do is I'm actually going to assign a main camera field. And this is something that we need to do because it's just kind of like an optimization move. Because we assign the main camera to a field inside our code, we have already grabbed the camera inside our code, so we don't have to re-grab it every single time we need to use it, which means that every single time I update my mouse movement inside the screen, because we need to use the main camera for that, then we don't have to re-grab the camera every single frame. And it just kind of like makes it a little bit more optimized. It's not something we're really going to notice in this small mini game here, but if you have a larger game, it is definitely something that can have an impact on your game. So we're just going to say we have a camera game object here, and I'm going to set it equal to a main camera. Next, we want to create a couple of fields for the actual movement of our player. So we have done that plenty of times before. I think we did that in the previous project that we created. So the first thing we're going to do is we're going to create a float for the vertical movement. So we're going to say _move vertical. The next thing we're going to do is we're going to duplicate this line and we're going to say move horizontal, because we also need to have horizontal movement. We're also going to have a move speed. So we're going to just go ahead and say we want to create a move speed, and we're actually going to assign this one, and we're just going to go ahead and assign it to 5F, just because that's what I found out as I was making this project for this video here is roughly the speed that we want to have. Figuring out these numbers here is just kind of like trial and error. So once you create your own games at some point, just kind of like mess around with the numbers and see what feels right. I just kind of like came to the conclusion that 5 is what feels right for this particular game here. So the next thing we're going to have is a speed limiter. And the speed limiter is there to kind of like help us, like decrease the speed of certain game objects if they are going too fast. So we're just going to go ahead and make sure we have that as well. Limiter. And we're going to set it to 0.7F, because if we multiply with this number, it's going to decrease our velocity essentially. So we can use this number to like do that. And then the next thing we're going to create is going to be our move velocity. So essentially the direction that we want to move. And there's a couple of different ways you can create movement using the vertical and horizontal inputs. We have done it in a different way in the past, and today I think we're going to do it in a new type of way. So essentially what I'm going to do is I'm going to create a vector 2, and I'm just going to set this one as move velocity. What this is going to contain is going to be the X and the Y axis of the movement. So we basically just take this and then we run it inside our update to actually move our player. I will actually get to show. It's a little bit different what we've done in the past, but it does the same thing. So now this is how to move our player, but what about the mouse? Because like I said, we're going to create some aiming with the mouse. So we're going to have a couple of fields for that as well. So I'm going to create a vector 2, and I'm going to say this one is going to be the mouse position. And then I'm going to create another vector 2, which is going to be the offset of the mouse. Next, we're going to create a reference to 2 different game objects. The first one we have actually created already, which is going to be the bullet spawn location, which is the tip of my tank. And then the second one is going to be the actual bullet that we want to instantiate, which means that we're going to create it and then shoot it in the direction that we're aiming. So the first one is going to be first of all, we're going to serialize field this because we have to be able to drag and drop it inside the Unity editor. So we're going to serialize field, and I'm going to say this is a game object. And it's going to be called bullet. Then I'm going to duplicate, and I'm going to say the second one is going to be the bullet spawn, which is the tip of the tank. So with these two, we can actually already now go inside our Unity editor. And I want to make sure that we have actually applied our script onto our player game object, because that's very important. So I'm going to take it, I'm going to drag it onto my player, and then you can see inside the editor we have the bullet and we have the bullet spawn. So I'm just going to go inside my player and say the bullet spawn is my bullet spawn player game object here. So I'm just going to drag it in, make sure we can actually see it. So we're just going to go ahead and drag it in here. So we're going to select our player and then drag and drop the bullet spawn into our bullet spawn. The next thing we're going to create is going to be a check that checks whether or not we're currently shooting inside our game. And the reason we have to do that, because it may seem a little bit weird that we need to have that. Like, why not just shoot a bullet and then just like, you know, whenever you press the mouse button or something. The reason we have to do this is because we actually have to instantiate the bullet and then fire it off using physics inside a fixed update method, which we haven't created yet. But we need to check for the mouse input inside our update. So if I were to check for the mouse input, which is much faster because there's many more frames happening inside the mouse input, but the physics frames are slower than inside our update method, because that's how it is as a default. Fixed update is going to be a little bit slower than update based on like your computer. So if you have a good computer, it's going to be slower. And it's going to create this wonky thing where sometimes you're like double firing and sometimes it doesn't fire at all. Like it's gonna mess things up a little bit. So we need to make sure that when we register a mouse click inside update, that we set our shooting, like are we currently shooting, to true. And then inside fixed update, once it picks up on it, then we set it to false afterwards. And it just like makes things a little bit smoother and makes it so that it actually shoots whenever we want it to, rather than it like double fires and then sometimes it doesn't fire. It's just like a weird thing that sometimes happens. So with that said, let's go ahead and create a Boolean. This one is going to be a is shooting. That is going to be set equal to false, because right now, as we're starting the game, we're not shooting. And then we also want to set a bullet speed. So we're going to set a float that is called bullet speed. And this one is going to be set equal to 15. And this is basically all the fields that we need to have. So I hope you wrote notes when I was explaining, so you know exactly what these things does. You will get to see them in action once we actually get down into like the start and the update and fixed update and, you know, other user created methods that we're going to create. The next thing we're going to do is we're going to go inside our start method. And the first thing we want to do is we do actually want to make sure that our game manager currently has something assigned to it, because right now it's just an empty field. It doesn't really have the script or anything inside of it yet. There's a couple of ways we can do this. Either we can actually find the game manager script inside our start method, which is considered to be the slower way to do it. Like, it's okay in this example here, since we are kind of like doing a very basic game, but in a larger game, you don't want to do .find a lot of times whenever you have to find something inside your game. So instead, what we're going to do is we want to go up here and say we want to serialize field our game manager. So we're going to say serialize field, and we're going to do the same thing as we did with the bullet spawn down here. We're just going to go back inside Unity, and then we're going to drag and drop the game manager inside the new little field that we have down here. Actually, it already filled it in, but just go ahead and drag and drop. If it doesn't fill it in for you, just drag and drop it in there. And go back inside your scripts, and that's basically it for the game manager. We don't have to do anything inside the start method in order to like grab the components of the script or anything like that, because we assign it using the Unity inspector. So with this, the next thing we're going to do is we're actually going to assign the rigid body component, because like you can see, we did actually create a rigid body up here. I'm going to go back down to my start, say rigid body is going to be equal to gameobject, which is the current game object we're attached to, which is the player, dot get component, parentheses, and then I want to grab the rigid body 2D. But we do need to do one more thing because we do also have a main camera. So we're going to go inside below our rigid body where we grabbed it, and we're going to say main camera is going to be equal to camera.main, because that is going to be the reference to the main camera inside our game, which is automatically going to be the camera that we have right up here. This one at the top here. And again, this is just kind of like an optimization move, so you don't have to like find the camera every single time you want to use it when we're like, moving our mouse cursor around. So this just makes it a little bit faster here. The next thing we want to do is we want to go inside update, and we actually want to grab the input of the player. So we're going to say we have our move horizontal, and that is going to be equal to input dot get axis raw, parentheses, semicolon. And then I want to make sure we grab the horizontal input. So we're going to say horizontal. Then we're going to duplicate this, paste it down, and we want to grab the vertical. And also make sure we change the name of the actual method or the field over here. So we're going to say vertical. So the next thing we can do is we can actually go ahead and grab the vector 2 that we created called move velocity. So we're going to take that one. And we're going to assign it to these two different horizontal and vertical axes that we actually grab from whatever the player has typed into their keyboard. So what I can do is I can actually take this one, set it equal to a new vector 2, parentheses, semicolon, and I'm just going to insert move horizontal as my x-axis, because it is the x-axis, comma, and then move vertical. Now we did also add a move speed that we have up here that we set to 5. So we're going to go ahead and take that and we're going to multiply our vector 2 with our move speed. So we actually have a little bit of a faster movement than just 1, because this is just going to be 1, or -1, or 0. So we want to make sure that it's going to be the actual move speed that we set inside our fields up there. And then the last thing I want to do inside update is I want to actually check if we had a mouse click, because if there was a mouse click, it means that we have to shoot, right? Because we want to grab all the different inputs that we're going to be applying to our keyboard inside this game here, or to the mouse and keyboard. So what I'm going to do is I'm going to run an if statement, and I'm going to be checking for a input that's a little bit different. Like we haven't talked about this one yet. Get mouse button down, parentheses. And then we want to grab the primary mouse button click, which is the left mouse button. Now that is going to be set to 0 inside the keybinds here. So 0 is the main mouse button. So once we get the input from the main mouse button, then we want to do something here. And in this case, we actually want to say that is shooting is going to be equal to true. Because now we grab the input from the mouse, which means that we're shooting, and we're going to set the code to be true, but we're not actually going to fire it using this particular update method here. Because like I said, some weird glitchiness can happen if we just shoot directly inside update. So instead, what I want to do is I actually want to go down and I want to create a void fixed update. Actually created there. Now don't worry about the private being in front of here. It is private by default, so you don't need to have anything. Just get confused about it. Now we're going to be using two different methods in here that we haven't created yet, because these are going to be user-defined methods, methods that we create. But we're just going to write them in here and then we'll create them afterwards. So the first one is going to be one called move player, because this one is going to take care of actually moving our player based on what the velocity is up here that we set. The second one is going to be called rotate player. And again, this is going to be based on our mouse movement, or the mouse position inside the game. And then I want to go down here inside fixed update and run an if statement. And I just want to check if is shooting is that equal to true. Then I actually want to shoot. And I'm going to do that using a coroutine, which is when we can add a time delay inside our code, because I want to make sure that our bullet gets destroyed after a certain amount of time, because if we don't destroy our bullets inside our game, they're just going to keep existing. And if I shoot off 2,000 bullets during my game time, it's going to be a lot of instantiated bullets just flying around somewhere in the ether inside our game. So we want to make sure we destroy the bullet after a certain amount of seconds after we shoot it. So we want to make that into a coroutine. So I'm going to say we want to start a coroutine that we haven't created yet. By the way, these are going to be 3 methods we haven't created yet. but we will do so in just a second. And I want to create a coroutine or start a coroutine called fire. So now what I want to do is I want to go below our fixed update, and I'm going to create a void method. And this one is going to be called move player. And as you may have guessed, that is the specific method that we're referencing to inside fixed update. Now we're going to do a couple of things here regarding like checking for movement. So the first thing we're going to do is run an if statement. And inside this if statement, I want to check for a horizontal movement. So we're going to say if there is a move horizontal and it's not equal to 0, which means that there is movement on the horizontal axis, or if there is a vertical movement. So I'm going to just copy paste this one and say move vertical. And basically what we're just saying here is that if there's any kind of movement on the horizontal or the vertical axis, then we want to move our player. So what I can do is I can take our rigid body, which is our physics on the player, say dot velocity, and then we're going to set it equal to the velocity that we set inside our move velocity. So we're just going to go ahead and set it equal to that one. Semicolon. However, this is going to create some wonky things inside our game. Basically, this is going to move us a certain speed in the, the horizontal and the vertical direction. But let's say I press the W and the D key at the same time, which means that I'm moving up, but I'm also moving right at the same time. It is actually going to double the speed, which we don't want to do. So we need to make sure we use our speed limiter in order to actually limit the speed that we're moving in a diagonal direction. Because if I were to actually play this, let's actually go ahead and do that so I can show you. So if I were to go inside my game, just to kind of show it off here, you can see I move really fast diagonally, but I move slow when it comes to the horizontal and up and down axes. So we want to make sure that diagonally we don't move that fast. So in order to prevent that from happening with the double speed, what I'm going to do is I'm going to copy the if statement and paste it inside its own if statement here, curly brackets. I'm just going to move this back so it doesn't look weird. And inside this if statement here, I want to check not if any of them have been clicked, but if both have been clicked. I'm looking up there because my camera used to be up there. So I'm going to change this to and instead of or. And then I'm basically just going to say I want to take move velocity and I want to multiply it and set it equal to the speed limiter that we set up there. So speed limiter. Let's actually make sure we do that correctly. Equal sign. There we go. Now, some people may say, well, Daniel, why don't you just normalize the magnitude instead? Because you can also do that. Yes, you can do that, and that would probably also be a solution. When I made this just on the go, I just created a speed limiter instead. But you can also normalize the vectors. So essentially that the magnitude, which we have talked about in a previous video, essentially gets limited down to 1, and then you can set like the move speed afterwards. So you could have done that, but in this case, we're just going to do a speed limiter. So with that, it is going to not move too fast in the diagonal direction. And now, of course, we do also need to make sure that our player stops again if we're not pressing anything. So we're going to say else, curly brackets, and then I want to say that we want to set move velocity equal to a new vector 2. Parentheses, and I'm just going to set this one to 0 and 0, just so we know that we're standing still now. Like there's no velocity happening. And then of course we do also need to take our rigid body velocity and set it equal to, actually we could have copied everything here, our move velocity, just so we know that it's actually stopping. And this is basically all we need for player movements. So what we're going to do now is we're going to go ahead and create a new method, which is going to be our rotate player method, which we actually created up here. Let's actually go ahead and uncomment everything that I commented here. And I'm going to say we have a void move player or rotate player, it's called, curly brackets. And inside rotate player, we're going to do some new stuff that we haven't talked about before, because this is going to be like getting the location of the mouse cursor, and there's going to be some methods in here that you will actually be using quite frequently inside Unity, but we haven't discussed them before, and they can be a little bit confusing to talk about. So if there's anything you get confused about here, look them up and just kind of like see what they do. I will of course explain them, but if you want more details on them, you're more than welcome to look them up inside Google, because that's a very good tool for any sort of developer. The first thing we're going to do inside rotate players, we're going to grab the actual mouse position. So because we already inside our code up here inside the fields said we want to create a mouse position and an offset, we're actually going to go and use those inside this method down here. So I'm going to say that we have our underscore mouse position, and I'm going to set it equal to input dot mouse position, which is actually a built-in property we can gain access to inside our code. Now, the next thing we're going to do is we're actually going to grab the location of the player inside the camera view. And we need to do that in something called world to screen point, which is something we need to use in order to compare the mouse position to where the player location is. Because when I move my mouse cursor around my player, I would like my player to rotate towards wherever the mouse cursor is. But if my player is like over here, let's say on the right side of the screen, it's actually going to rotate based on where my mouse is based on the screen, but not compared to the player. So we need to make sure we also add in something called a screen point, or like a world to screen point, where we take the player's location based on the camera. So we're going to go in here and we're going to create a vector 3. And I want to call this one screen point. Now I want to set this one equal to the main camera that we grabbed, because we did actually grab the main camera. So we could actually just like see, for optimization purposes. So we're going to take the main camera and say dot, and then we want to use a method called world to screen point. Inside of here, we're going to give it the location of our player. So we're going to say transform dot local position. So now that we have this, we can now compare the actual position of the player to where the mouse cursor is on the screen, because this is just something you're going to have to do if you want to compare game object location based on like the mouse or something. So what we can do now is we can actually go ahead and take our offset, which we have created already, and set it equal to a new vector 2, because we don't want to have a vector 3, because otherwise we can also rotate our player inwards or outwards, which we don't want, so we get like a flat object inside our scene. We just want to have the horizontal and the vertical axes. And we want to make sure we grab, first of all, the mouse position on the x-axis. And we want to minus that with the position of our game object inside our screen based on where the camera is. So we're going to take our screen point dot x, comma, and then we want to do the same thing, but for the y-axis. Again, if you're a little bit confused about what we're doing here, look up the episode that I created where we talked a bit about magnitude and figuring out the offset. Like, it's in this course here. So if you missed that one, or if you don't remember it, you can always go back and just kind of look it up. But this is basically how you figure out the offset. Essentially just minus the location of the game object with another game object, and then you can like figure out the offset between them. Now we do need to do something else here, which is normalizing this vector here, because right now the next thing we have to do is we actually need to figure out, so which rotation do we need to rotate towards in order to rotate towards the mouse cursor. And in order to do that, we don't want to have the vector be like this crazy large number. We just want it to like even out to like a 1 once we're actually rotating with the axes. And doing that is something called normalizing. So we're going to say dot normalized after we have this vector 2. And this is going to give us basically, I can actually go ahead and, let's go ahead and see it inside the console here. I want to show you what I mean. Debug.log. Let's actually go ahead and debug the offset so we can actually see it. Let's actually make sure we don't have any error messages happening here, so we don't, so we can actually run the code. If I were to go ahead and remove the normalized and show you inside our console as we're playing the game, you'll actually see that we're getting these crazy numbers based on where the mouse cursor is. So we're going to play it, and then you can see we get these like 525 and 244, and based on like my movement, it's going to change. We don't want to have these crazy numbers here because it's going to actually change the bullet speed. So if my mouse is like really close to my player, it's going to shoot very slow. But if my mouse is all the way up here, it's going to shoot very fast. So what I want to do is I want to normalize the vectors by saying this dot normalized, which is actually going to give us a completely different number because it's going to add up to 1 now. So it's still going to give us a rotation, but it's going to add up to 1. So you can see right now it's like 1.0 and 0.1. Like it's not like crazy numbers at all, which is going to be much better for setting the speed for our bullet to fly. So basically what I want to do now is I want to go down and I want to get the angle that my player needs to rotate towards based on the offset here. So basically we're going to create a float, and this one is going to be called angle, just so we know what angle this is going to be that we want to rotate at. Then I'm going to set it equal to math f. And we're going to use a method called atan2. And this is one that you haven't seen before. Essentially, it's going to take the angle between, like, if you have an offset, it's going to figure out the angle between them. So what we can do is we can take the offset and take the x-axis and then we're going to take the offset and the y-axis, and it's going to give us like the angle between these two game objects here. Next thing we want to do as well is that right now this is actually going to give us this number as radians, which is another unit that we can use in order to calculate rotations inside Unity. So I want to convert this into degrees so we can actually use this properly. So I'm going to say multiply with math f dot rad to degree, which is radians to degrees. So just converting this one unit of rotation into another unit of rotation. So now that we have all of this, we can actually go ahead and rotate our player towards the proper angle that we need to be rotated towards to point towards our mouse cursor. Now, we're going to be using transform.rotation. And yes, I did actually mention that we should not mix in transform-based movement with physics-based movements early on in this video here. But because this is like a rotation that is transform-based and the movement of the player is physics, like it's not going to like go against each other, this is okay. So just going to go ahead and rotate using rotation. I'm going to set this one equal to quaternion dot Euler, which is a way for us to rotate something towards a certain angle. It's just going to snap rotate towards it. And we're going to set this one to 0f, 0.0f. And then we want to grab the angle, because this is actually going to be on the z-axis that is going to determine the rotation here. You'll know that if you go into the Unity editor and actually try and rotate an object, you'll notice that it's the z-axis that we have to manipulate to rotate in 2D. And then I'm going to minus this one with 90 degrees. We do actually need to correct something here because I made a typo. We do actually need to, inside the atten2 method here, change it so that it's the y-axis first and then the x-axis afterwards. Otherwise, it's going to mirror its rotation, which we don't want to do. So with that, the reason that we added in the minus 90 here at the end, by the way, is if I were to actually go ahead and save this one and go inside my game just so you can test it out, you'll actually notice that my game object is actually rotated improperly. It is rotating towards my mouse cursor, but you can actually see it's rotated. So we need to rotate it 90 degrees in order for it to actually point the right direction. So going into our code again, minusing 90 degrees, going back inside our editor, you'll actually notice that now it is going to point the proper direction. So there we go. It's actually pointing, and it's not like bending into like the depth axis or anything like that. It's actually rotating like we want it to. So we move around, and now we just need to shoot something as we're moving. And that is actually going to be the last thing we have to do inside our player controller. So I'm going to go down to the next line here, and we're going to create a IE numerator, which is going to be called fire. So we're going to actually fire off a bullet inside this enumerator here. So inside fire, what I want to make sure we do is, first of all, the first thing we have to do is we need to make sure that the is shooting is set equal to false inside this one. And again, the reason that we have to do this is because my update method is running super fast compared to fixed update. So once we set this one to true, we don't want to shoot. We just want it to tell our code that we're allowed to shoot now. So inside fixed update, we're going to say, okay, if we're allowed to shoot, then run this coroutine that we just created here, which is actually going to go and say, okay, now we register the shooting. So set this one to false again, because now it's okay. And then we're actually going to fire the bullet off. So in here, I'm going to say we have a game object, and this one is going to be called bullet. I'm going to set it equal to instantiate, because we actually want to instantiate the bullet, which we haven't created yet inside Unity, but we will. We want to instantiate the bullet. So I want to say parentheses, semicolon. And then inside here, we need to actually grab the game object that we want to shoot off. We did actually create that one at the top already. So we're going to say bullet. And then I want to say, okay, where do you want to spawn the bullet at? So we're going to say we want to do it at the actual spawn location from bullet spawn, which we did already create as well. So we're going to say bullet spawn dot transform dot position. And then the last one is going to be the rotation. So again, quaternion is like the default for rotating something inside Unity. So we're going to say quaternion dot identity, which is just basically saying that it's not going to rotate it. It's just going to stay whatever when it spawns in. So with this, we now actually need to create a bullet because we haven't done that yet. So we're going to go into Unity, and I'm going to go ahead and create a 2D object, which is going to be a sprite. It's going to be a circle. And this one is going to be called bullet. Now I'm going to reset the transform. Actually, we can just move it up because that doesn't actually matter. And I'm just going to decrease the scaling. So we have something that has the size of a bullet. So we're just going to say like 0.3 on both the X and the Y axis. And let's make this a different color. Let's make it something like yellowish, just so we have something that looks different from any other game object inside the game. We do also need to make sure we add in a rigid body 2D and a circle collider. So we're going to start with rigid body 2D. And we're also going to add in a circle collider. Now, to begin with here, let's actually go ahead and change the rigid body a little bit. So the gravity scale is going to be set to 0 because we don't want it to fall down once we start shooting. We do also need to set the collision detection to continuous and interpolate to interpolate. And that's basically all we have to do here. Now, what I want to do, since this is going to be a game object that we're going to reuse multiple times, is that I want to go back inside my assets folder and drag and drop this bullet inside my prefabs folder. So we actually create a copy of this game object that we can use over and over again. So we can actually go and delete it now from inside my scene. And I'm just going to go ahead and click my player, go down to where we have the script, where we have nothing set to the bullet. And I'm just going to drag and drop my bullet into my bullet. Save it, go back inside my code. And now we basically have a bullet that we can shoot that is actually getting fired off here. Now, this is just going to instantiate the bullet. It's not actually going to make it go fast or anything. So the next thing I want to do is I want to go below here and I want to take the bullet that we instantiated and I want to get a component because we want to grab the physics component of this bullet and I want to grab the rigid body 2D and I want to say that we want to change the velocity of the bullet and set it equal to the offset that we created further up there because we have an offset. And I want to multiply it with the bullet speed. So bullet speed. And this is just basically going to shoot it off in the direction of the mouse cursor with the bullet speed that we chose. And if we had not normalized it up here, this would actually have been fired off much faster if my mouse cursor was further away from the player than if it was closer. So we needed to make sure that the normalize was actually added up here. So with this, we actually have everything that we need. It is kind of throwing us an error message here, and that's because right now we also do need to tell it that we need to wait a certain amount of seconds, and then we want to destroy this bullet so we don't have like a million bullets inside our scene at one time. So what I want to do is I want to go down here and I want to say yield, return, new, and then I want to say wait 4 seconds. And then I want to tell it how many seconds I want to wait. In this case here, let's just say 3 seconds. Then I want to go below and I actually want to destroy bullet, like so. And now we have everything working in terms of like the player. So we can actually go back inside our Unity and test this out so we can actually see things. We have no error messages, that is good. And now when I move around, let's actually deselect everything. Now when I move around, you can see we're shooting a bullet. Hey, it's working, right? So now that we have a working player that we can use inside our game, the next thing we're going to have to do is create a enemy because we need something to follow the player and then they have to kind of like, either the enemy has to like reach the player first and destroy the player or the player has to shoot the enemy before they get to it. So I'm going to go inside my hierarchy and I'm going to do the same thing as we did with the player. I'm just going to go ahead and create a game object that is going to be in 2D and you can create something that looks like anything you want it to look like. I'm just going to create a capsule here. I'm going to call this one enemy. And I'm going to just reset the scale or reset the transform. And I'm going to color it a different color so we know exactly what this is. Now my bullet is orangey yellowish. So I'm going to make this one maybe like red. Actually, you know what? The complementary color to blue is actually orange. So let's make it completely orange. So something like this. And what I'll do is I am going to go ahead and create a face for my enemy because right now we can't see what the front part of the enemy is. So I'm just going to right click on my enemy, create a 2D object, and I'm going to create let's create a circle and just kind of like place it in there. So I'm going to say head, just so we know exactly what part of the enemy this is. And I'm going to make it a different color. So I'm going to go ahead and make it the same color as the enemy to start with. And then I'm just going to make it maybe a little bit more red. just to kind of like give it a different color. Now, of course, right now we can't see anything because the ordering inside our layers here is not set up correctly. So I'm going to set this one to 10, just so we can see what this is. Then I'm just going to move the head up so we have the head at the top there. So like 0.5 on the y-axis. So now that we have an enemy, we can actually start doing things to it. Like maybe we want it to follow the player or do something like that. But first we need to add some components to it. So we're going to go inside our enemy, not the head. And I'm going to go ahead and add a component, which is going to be a rigid body 2D. Then I'm going to make sure that I set the gravity to 0 because we don't want it to fall down. I also want to make the collision detection continuous and interpolate to interpolate. And I'm just going to go ahead and move down and add a collider. So I want to have a capsule collider 2D because we want the entire capsule to not touch the player, or otherwise you die. So we're going to go ahead and add that one, and that is pretty much it. Now we do need to add a script to this enemy because we need the enemy to do something inside our game. So I'm going to go ahead and go inside my scripts folder. I'm going to right click and I'm going to create a new C# script that I'm going to call enemy behavior. I didn't spell that correctly. Let me just delete it and try again. Enemy behavior. There we go. Okay. Now, just FYI, if you misspelled the name of the file, you can't just rename the file, but you're also going to have to open up the file and rename the class of the file, just so you know exactly how to fix that if that happens to you, or if you want to change the name of a file at a certain point later on. I just thought it was easier to just kind of delete it and create a new one here. So I'm going to go ahead and drag this onto my enemy. And with this, we now have a complete enemy. Like there's nothing else I want to do to my enemy here. So what I'm going to do is I'm going to go back inside my assets folder and I'm going to create a prefab out of it because the enemy is going to respawn again and again and again inside my game. So we might as well just make it into a prefab that is going to be, usable to us again and again and again inside our game. So I'm just going to go ahead and delete the enemy up here. Now, just a small tip here. Often when you create a game like this, or just any kind of game, I know that we don't plan to create duplicates of our player right now, but usually you do actually also make this into a prefab just so you can at some point reuse the player if you need to. Let's say the enemy, gets destroyed, and you might want to, without having to end the game completely and have to start up the game again, you might want to be able to spawn in the player once more. It's just good to have a prefab of the player as well. So let's actually go ahead and do that. I'm just going to drag the player in here, and that's pretty much it. So with this, what we can do now is I can actually go ahead and open up my script, because we did actually create our enemy behavior script. And in here, we're going to go ahead and create the actual behavior that is going to be happening with this enemy here. So like following the player and, rotating and stuff like that. So what I'm going to do at the beginning here is I'm going to create the fields. So I'm going to start by actually referencing to our game over field that is inside the game manager. So I need to serialize field a game manager, which is going to be a game manager. Let's just go ahead and assign this immediately. So let's go ahead and go inside our game. So we're just going to open it up here. Now, whenever you have to manipulate a prefab, because right now we don't have the enemy in here, so how can we select it, right? What you do is you go inside your assets folder, go inside prefabs, you click on the enemy, and then you don't start changing it here. You actually need to open up the prefab so you can make changes to the prefab itself. And then you go down here and then you can start dragging and dropping things in here. Now, there's going to be an issue though, because right now we can't drag anything from inside the hierarchy into our game manager here, like the little slot we have inside our enemy. And the reason for that is simply you're not supposed to. You're not supposed to be dragging game objects from inside the hierarchy into a prefab, because prefabs are supposed to be reusable. So if we have something from inside the hierarchy that only exists inside the hierarchy, which may just be used once inside a specific scene inside our game or something, it's going to break the game object that we have as a prefab, because now all of a sudden it doesn't exist in level number 2 or something like that. So you're not supposed to be dragging a game object from inside the hierarchy into a prefab. We have a small issue here though, because we have a game manager. If I were to go back here outside my my enemy, we have a game manager right now that has a script attached to it, and we're supposed to be able to access this script from inside our prefab. Like I said at the beginning of this tutorial, usually when it comes to any kind of manager inside your game, like a unit manager or a game manager or a save manager or something like that, you would take these managers and the script that you have attached to them, you would convert into a static class, which means that you can access the class from anywhere without having to create a reference to it first, like we do inside our script up here. So we kind of run into a small issue here because we're doing things in a slightly unorthodox way because we haven't talked about static classes yet. So how do we access the game manager without doing anything with static classes? On top of my head, I know there's 3 different ways we can reference our game manager from inside our script here. The first one would actually be to use a static class. Hey, we talked about that. We can't do that. At least we're not going to because we haven't talked about it yet. The second way is actually to go inside our start method. And I'm actually going to go ahead and delete the serialized field because now we don't actually need it anymore. And I'm going to say I want to reference our game manager. I want to set it equal to gameobject with a capitalized G. Dot find parentheses, and then I want to reference our game manager. So essentially this is going to be searching our hierarchy for a game object that has the name as game manager. Now this is going to be the slowest possible way to find a game object inside your game. Like, this is considered to not be the best way of doing things. Because we're building a small game here, of course this wouldn't matter at all because we can't feel the impact of using .find. But in a larger game, you probably wouldn't be using .find because it is considered to be a slower way of doing things and it will slow down your game considerably. Another way to do it would actually be to use maybe .find with tag or find game object with tag, which is another way of searching for game objects inside your scene, but just based on tags instead of the actual names of the game objects. And because, tags have fewer game objects that might have that possible tag, it's slightly faster, but it's also considered to be a little bit slow. I do also believe you can search for game objects based on if they're a child or a parent, but it's not something I've used in the past, so it's not something I'm going to talk too much about. But like I said, we're not going to be using static classes in this case here, so we're just going to go ahead and use .find since it's not really going to do anything, special in terms of like performance on our game here. It's just a tiny game that we're building. So we're just going to go and use this one. I do want to mention one other thing though. And that is that if we were to go back inside our inspector, you can actually see that currently if I were to go inside my enemy and open the prefab, there is one way we can actually reference to a script on a game object, like for example on our game manager, and that is if we're referencing to another prefab. So if I were to actually say, you know what, I need to grab a script that is attached to my player, I can actually take my player inside the prefabs folder and drag it into the slot up here. So just to mention that you can do that, and that is actually considered to be the way to do things. Again, like I said, it's only because we haven't talked about static classes yet that we have to do the small hack here in order to find our game manager. So in this case here, in this tiny little example here, the little project we're doing, it's okay. So what I'm going to do as well is I want to actually say, okay, so now we want to find the game manager, but I do also want to find the actual component onto the game manager, which is my script. So I'm going to say get component, and I want to grab the game manager script. And just like that, we now have access to our game manager scripts. Now, the next one we're going to create is a game object type, and we're going to reference to our player. Now, here's the interesting part, because we have talked about this. We could go down inside here and duplicate this and search for a player, but we talked about this being like the slow way of doing things. But because our player now is a prefab, we can actually go inside our serialized field and do what we couldn't do with the game manager. So I can go inside here and say serialized field. I can go inside my Unity editor. And I can actually go ahead and say, okay, you know what? Now we do actually have a player reference that is right there. And I have my player right here. So I can drag this in. And now it's going to be working because I'm referencing to my player here. So with that, we can now go back inside our scene or inside our script here. And the next thing I'm going to do is I'm going to create the health for my enemy here, because we need to have a couple of stats in this enemy for it to actually work, because we need to be able to kill it. So what I'm going to do is I'm going to create a float. And I'm going to call this one enemy health. And I'm going to set this one equal to 100F. Because why not start with 100? You can always increase this if you want the enemy to have more health, or if you want the player to do more damage at some point, we can do that. Now, we do also want to have a move speed of this enemy, so we want to have another float. Float. And I want to call this one move speed. Actually, we can call it enemy move speed. So enemy... I can't spell right now. Enemy move speed. We do also want to create a target rotation, which is going to be, aiming towards the player at all times. So once my player is moving around on the screen, the enemy should constantly be rotating in order to actually see the player. So what I'm going to do is I'm going to create a quaternion, because that is the name for rotations inside Unity when it comes to programming. And I'm going to create a target rotation, because that is the next rotation we need to rotate to inside each frame. And then I do also want to have a boolean that is going to be named disable enemy. This is just kind of so we can disable the enemy, so that once we hit the enemy, it's going to stop moving for a second, and then, after a couple of seconds, it's going to chase after the player again. So we're going to go ahead and set this one to something like false, because we don't want to have it disabled at the beginning of the game. So now that we have this, we can actually go inside our update and actually start doing things with this enemy. So what I want to do is I want to create an if statement, and I just kind of want to check if we have game over set to true inside the game, because if things are game over, then I don't want to move my enemy, right? And I also want to check if the enemy has been disabled, because then I don't want to move the enemy either. So inside my if statement here, I'm going to reference to my GameManager, because we have a game over statement in there that we need to check for. So if GameManager dot underscore game over is actually set to true, which means that we're not going to have anything in front of it, or if our disable enemy is currently set to true, because that means that that is disabled as well, then we don't want to run anything in here. Now, of course, right now we are checking to see if these are set to false, both of them, because we're going to run some code if the enemy is allowed to move inside our game. So we do actually need to have an exclamation mark in front of them. So inside the if statement, what we're going to do is we're just simply going to reference to two methods that we haven't created yet, which are called move enemy. And we also want to reference to one called rotate enemy. And then below update, we're going to go ahead and create these two methods here so we can actually use them. So I'm going to take my move enemy and I'm going to do something in here. We do want to set this one to a void method. And I'm going to go ahead and start by saying that we want to actually just kind of like move towards a certain point inside the game, which is going to be the player's transform location. So I'm going to say I want to transform dot position, and I want to set it equal to vector 2 dot move towards. Now, move towards is not a physics-based movement. It's actually a transform-based movement, and this is a physics-based game object, and we're kind of like going against my rule here because you're not supposed to be mixing the two. We do need to do one thing here, which is to go inside our inspector. And inside our enemy, we do actually need to add a drag. The reason we have to do this is because right now, if I were to hit the enemy with a bullet, he's actually going to, because he has physics attached to him, he's actually going to move a little bit behind, like kind of like, oh, he's floating because he's disabled. And then I'm going to start telling him to move towards my player again. But because the knockback effect is a physics-based movement and moving towards my player is not a physics-based movement, it's going to start jittering once we do that. So what I want to do is I want to add enough drag for my enemy to actually stop moving once he gets the knockback, so we can actually start moving using the transform again without having to like fight against the physics. So what we're going to have to do here is we're going to have to add a drag so we can stop the game object after it gets knocked back. And I'm also going to go inside my angular drag and just give it a, just a little bit of a number here, so we also stop the rotation when it comes to the physics, because it can also rotate once you get the knockback. So we're going to add 5 to each of these. Inside the enemy game object, of course, make sure you open up the prefab first by saying open prefab. And once we've done that, we're not going to encounter that issue I just talked about, okay? So what I'm going to do inside move towards is we're going to tell it where we want to start from and where we want to go, and then how fast do we want to move. So I'm going to say we want to start at transform.position. Then I want to go towards my player, which is actually the player reference that we had up here. So the player dot transform dot position. And then I wanted to go in a move speed. So we're also going to say we had underscore move speed, or enemy move speed is actually called, times time dot delta time. Now, we did talk about time.delta time at some point in one of the previous lessons, so hopefully that's not going to confuse you too much. Essentially, we're just like making sure that, depending on the frame rate, that it's not moving faster if you're on a fast computer or if you're on a slow computer. So we're just making sure that the movement speed is always going to be constant by using time.delta time. So with this, we are actually done with the move enemy. I'm just going to go and duplicate it, paste it down below, and I'm just going to call this one rotate enemy. I'm just going to go and delete the code that we have in here. Just going to scroll down so we can actually see things. And now we want to make sure that the enemy is constantly rotating towards our player inside the game. In order to rotate our enemy, we do actually need to have a move direction. So we do actually need to go back up inside our fields. And I'm just going to go and create a vector 2. Should have created this at the beginning. I just kind of missed it here. So we're going to call this one move direction. And then I'm going to take the move direction and I'm going to go back down inside rotate enemy and paste it in. And then we're going to set it equal to player dot transform dot position minus the transform dot position. And if you have followed up until now, you will actually see, you'll know what exactly we're doing here. We're actually creating a offset right now, which means that we're getting the magnitude, which is the direction towards the player. Again, we talked about this in the previous lesson. This is like the offset and magnitude talk again. We do need to do one thing here though, which is that we need to normalize this because like I said, with the player movement as well, when it came to the bullet, we do need to make sure that depending on how far away the player is, that we're not moving faster because these numbers are going to be like really, really big if the player and the enemy are like super far apart. So we do need to normalize this. So we're going to, at the bottom here, say dot normalize parentheses. So now that we have the offset, we can actually go ahead and start rotating this enemy towards the player. So what I'm going to do is I'm going to set the target rotation and set it equal to quaternion, because again, that's our word for like rotation inside code. And I'm going to say dot look rotation, which again is a transform based movement. It's not physics based. The first thing I want to add in here is going to be what part of the enemy do I want to rotate towards the player. And in this case here, it's going to be the tip of the player. So I want to say we have a vector 3 dot forward, which is going to be that direction that is pointed upwards. And then I want to tell it that I want it to rotate towards our move direction. And this essentially here is just giving us, you know, the look rotation, like how much do we need to rotate in order to rotate towards the player. And the next thing I want to do is I actually want to add in a smooth rotation. I don't want it to just like snap towards the player. But before we do that, I would actually like to do an if check, because in order to optimize our game, we don't want to run garbage code, which is basically code that is not needed to be run at all times. So if my transform dot rotation is currently not the same as my target rotation. Essentially, this is just going to make it so that if I'm already pointed towards the player, we're not going to do another rotation. Like it's just going to stay where it is and not run this rotation again, because there's no need for it. So by doing this, we avoid running code that is essentially not needed to be run every single frame. So that's just kind of like a really neat way to do things. So inside the if statement, what I'm going to do is I'm going to take the transform.rotation of my current enemy here. I'm going to set it equal to quaternion. And then I'm going to run a rotation method that is going to be called rotate towards parentheses. What I want to do here is I want to tell what is the current rotation that I want to start at and what rotation do I want to rotate towards and how long do I want it to take. So I can actually go ahead and say transform dot rotation, which is my current rotation. Then I want to take my target rotation, which is where I want to end up after a little bit. And then I want to tell it how long it's going to take. I've just kind of like fiddled with the numbers just to see what fit me the best. And I'm just going to say 200 here times time dot delta time, because that is important because we're using this inside an update method up here. So with this here, we do actually have everything that we need in order to get the rotation working as well. So what I can actually do is I can actually go inside my game and just kind of like test things out. So by going inside the game and letting it load in for a second here, it's going to give me a small error message here because we haven't actually assigned anything to the enemy health yet. That's fine. And I'm just going to go ahead and drag in my enemy into the scene. So I'm just going to place him right here. I'm going to play the game. Then we're going to see what happens here. So as you can see, oh, it starts aiming towards my player, and it's actually kind of messing up a little bit here. We made a small mistake. Now, I did mention earlier that we could actually take a prefab and drag into another prefab inside the inspector. This is only going to work if we want to grab certain elements or components inside that particular prefab. If we want to track the location of that prefab, it's not going to work in this way because we're only going to get the starting position. So what I do need to do is I need to go back inside the hierarchy and I need to track this particular prefab and not just the general prefab file inside my scene. Which means that we're going to have to go back inside our code, and instead of just referencing to the prefab itself, we're actually going to have to reference to the one inside our hierarchy. So we're going to delete the serialized field again, and I'm going to go inside my start method, and I'm going to say that I have a player that is going to be equal to gameobject, and then I'm going to reference to the other one, which is find game objects with tag. Actually, it's going to be game object, not with the S behind it, because that is if we want to find something that needs to be put inside an array. So just a singular one. And then I want to reference to a tag called player. So now what I can do is I can go inside my inspector. I can go inside my player. And I want to make sure that my player right now has a tag set to player. So as you can see, we do actually have a tag here that is called player, which is created as a default for us. So if I were to tag that, save the game, you can actually see that my enemy is now following the player. Of course, we're not destroying the bullet. We're not destroying the enemy just quite yet. And when they touch, we're not destroying the player yet. So there's many different things we still need to kind of like fix here. So what I want to do is I want to go back inside my code. And we're going to go back down to our rotation because we have to add something in down here at the bottom. I do believe we've talked about this one. I may be wrong about this, but I do remember a lesson at some point that I've done on this. We're going to do something called on collision enter 2D. So I'm going to say on collision enter 2D, and it's just going to like auto create it for me. Now, for people who forgot about it, the collision variable that is inside the parameter here is actually a reference to the game object that we're colliding with inside the game. So if my player touches this enemy here, then the player is going to be equal to the collision variable. If the bullet touches my enemy, then that one is going to be equal to the collision variable here. So what we can do is we can actually start doing things here. So what I want to do to start with is I want to run a check, just an if statement. And I want to check if the game object that we're touching right now is the bullet. So I can say if the collision dot game object dot tag, because we can actually search for a specific tag, is equal to bullet, then do something. And we do actually need to make sure we have two equal signs here, so we're not setting it equal to something. Then I want to go below here and I want to create a else if statement. Else if, parentheses, curly brackets. I want to also check if the collision is going to be equal to player, because we just added the player tag onto our player, which does also mean we need to go back inside the inspector, and inside the bullet that we have down here inside our prefabs folder, we're going to go and open up the prefab, and we're going to tag it as bullet. Now, right now, I do actually have a tag called bullet. You could actually go ahead and say add tag, create a new one, and then just name it as bullet. So you go in here and you create a new tag. That's the way I've done it. I did it beforehand, so that's why I have mine. So you can just go ahead and do that. So inside the prefab, you just want to make sure that you tag it as bullet. So the first thing we want to do inside this code here is to check if we're actually getting hit by the bullet. If so, then I want to disable the enemy for a couple of seconds until he starts moving again. So we're going to run a coroutine, which is actually called damaged. We haven't created that coroutine just quite yet, but we will. So start coroutine. And we're going to call this one damaged. And then I'm just simply going to copy the name. I'm going to go below here and say I want to create a IE numerator. And this one is just going to be called damaged. Now, remember, a IE numerator is just going to be a timer. I think we did actually do that already inside our player controller when we had to destroy the bullet. So inside of here, what I simply want to do is I'm just going to go ahead and copy paste the line of code from inside our bullet, which is yield return wait for seconds. So I'm going to copy that line of code. Go down here, paste it in, and I just simply want to, right before we wait for those seconds, I want to actually disable my enemy. So disable enemy is going to be equal to true, which means that now the enemy is not going to be moving. And then we're going to wait for a couple of seconds, or maybe just like 0.5 seconds. And then I want to go ahead and set enemy disable to false, or disable enemy to false. And that's pretty much what we had to do in there. So going inside our bullet collision again, I'm going to go below here. And what I want to do is I want to decrease my enemy health. And I'm going to set this one to minus equal to 40. Again, you can set this to whatever you want. If you want the enemy to take many more bullets, then you just lower this number here. If you want it to get destroyed in 2 hits, then you just increase it to 50, since that's going to add up to 100 with 2 hits. You can do whatever you want to do with these numbers here. And then I just simply go down and run an if statement where I check if our enemy health is going to be equal to or lower than 0. Because if it is, then I want to destroy my enemy. So I'm going to say game object Now we do also want to destroy the bullet so it doesn't bounce off the enemy. So I do also want to go down below here and just say if the bullet hits the enemy, then destroy it. So we're going to go ahead and say collision dot gameobject, which means that we're now destroying whatever we collided with, which is the bullet, because that's what we're searching for here. Inside our collision, when we check for the player, we're going to do a lot less code. We're just simply going to go in and we want to say that we want to set the GameManager dot game over, and we want to set that one equal to true, which means that now everything is going to just stop inside the game because we did a bunch of checks inside our code to check for game over. So once this is set to true, it means that everything is going to stop working, right? So I do also want to make sure that I do set my game object that is being killed, which is the player here, because the enemy actually hit my player, is actually disappearing from inside the scene. So I want to say that I take my collision dot game object dot set active, which means that we're not actually going to destroy this game object. We're just going to make it like invisible so we can start the game again at some point. And I'm just going to set this one to false. So it's not going to be active inside the scene, but it's still going to be there. It's not going to be destroyed. So with this, we can actually go back inside our game, and you can actually see we now have kind of a game that we can play. If I were to go ahead and press play, you can now see that my enemy is going to follow my player. I can shoot it 1, 2, 3, and then it's going to get destroyed. However, if my enemy were to actually touch my player, something different is going to happen. We're going to, oh no, we don't reach it in time, and it destroys my player, right? Now, I did actually make a typo inside my code because we do actually need to check for ands and not or inside our update method here to check if we want to actually use move enemy and rotate enemy. So make sure you correct that. And doing that, we can now go back inside our game and test things out. So if I were to play the game, you can now see that if my enemy follows my player, it gets hit. We actually have a knockback effect. If I shoot my enemy again, it actually gets destroyed. If I play and actually let the enemy touch me, then you can see that, we now end the game because it now touched the player. So with that, we now actually have a working kind of like prototype of a game here. But I do want to make this a little bit more fancy. Let's actually have some spawn points around the map and just like have the enemies keep spawning in one at a time. And then at some point, it's going to spawn faster and faster and faster. And then until you can't keep up anymore, it's going to destroy the player. So what I'm going to do is we're now going to create the last script from inside our project, which is going to be a spawn points type script that is going to take care of like spawning the enemy. And we're going to create the actual spawns that are going to be the locations of where the enemies are going to pop in. So I'm going to create a new empty game object, and I'm going to call this one spawn points. Then inside my spawn points, I'm going to create another empty game object that I'm going to call spawn point 1. And then I'm just going to duplicate this one. We're going to have 8 different spawn points. So we're just going to duplicate it 8 times. And what I'm going to do here is I'm actually going to tag these, or not tag them. I'm going to make them visible inside the inspector. Because right now, as you can probably see, if we were to actually go inside spawn points and reset that one, we can't actually see these spawn points. It's just kind of like shown as a little white circle. So what I'm going to do is I'm going to highlight all of them, go inside the inspector, and say I want to create an icon for these. I'm just going to make something that looks something like orange. So now we can actually see an icon that shows us where these game objects are and actually tells us the name of them. So I can now take spawn point number 1 and just kind of like move it wherever I want it to be outside the circle. So in this case here, I'm just going to take spawn point number 1. I'm just going to move it over here, and it's going to have something like -9. Then I'm going to take spawn point number 2. I'm going to say -9 again. Move it down just a little bit. I'm just kind of like place them wherever you want it to be. Like you can really do whatever you want here. Place them, all in the top if you want to do that. I'm just going to place them all around in a circle so we have something that the player can actually work with here. So I'm going to say this is spawn point number 3. That is going to be -5. Let's probably make this one into -5 as well, just so we have something. And I'm just going to keep doing this, and you just kind of like do it at your own pace. So something like this. Now I have like spawn points all around my player here. So what I can do is I can actually go ahead and delete the enemy because we don't actually need him. And I'm going to create another script inside my assets folder. So I'm going to go inside scripts, and I'm going to right click, C# scripts, and I'm going to create something called enemy spawner. Actually, let's just go ahead and rename it into enemy spawn. So I can actually show you how to fix mistakes here if you want to change any kind of like file names inside your project. If I were to actually change the name of it into enemy spawn, it is going to give me a error message, because right now, if I were to actually open this up inside inside my Visual Studio. Right now, because this one is called enemy spawner, this is actually going to throw me an error message. So we want to make sure we change that name as well. Okay, so with this, we can now get started on creating the last thing we need in order to actually get this working, which is the enemy spawn that actually spawns in the enemies that are going to follow our player. So at the very top here, we're going to create, first of all, our fields. So we're going to go down and say we want to create a serialized field. And we can actually make this into a serialized field that is going to grab the game manager, because this is not going to be a prefab that we're going to create inside our game. So this is actually just going to be something that's inside my scene. So I can therefore drag and drop my game manager inside as a reference using serialized field. So saving this, I'm just going to go inside Unity. I'm just going to go into my spawn points, make sure that I have my script attached to it, drag it up there. And I'm just going to go ahead and say I want to take our game manager and paste it in there. Now, the next thing we're going to do is something we have talked about in the previous episode, is we're actually going to make an array, because I want to grab all the different spawn points that we created that were child elements of this game object here. So I'm going to go inside and say I want to serialize field, just so we can see exactly what is going on here. And I want to go ahead and say I want to create a game object that has to be an array. And then I want to call this one something like spawn points with an S behind it, because this is plural. Then I want to go ahead and go down to the next line. Actually, let's just go ahead and duplicate this. I'm going to delete the array, and then I'm instead going to call this one enemy. So now what we can actually do is we can go inside Unity, and then you'll actually notice that we get a bunch of things inside the inspector that we can actually add to this list here. So I'm going to say we want to add one element, which is going to be spawn point number 1. I want to add another element, which is going to be spawn point number 2, and then another one. And we're just going to keep adding these in until we have all of them. So spawn point number 4, number 5, number 6, number 7, and number 8. We do also need to tell what the enemy is. So we're going to go back inside our assets folder and get our enemy prefab. And then we're going to drag that in to our enemy slot that we have here. So now we just need 2 more fields. We need to tell what the spawn timer is, and we need to tell it how fast we want to increase the rate of spawns over time. So it becomes faster and faster and faster. So the first one we're going to create here is going to be a float, where we call this one something like spawn timer. And then we're just going to set this one to 2f. So it's every 2 seconds essentially. Then we're going to go down to the next line. We're going to create another float. This one is going to be spawn rate increase, going to be equal to 5f. So I believe every 5 seconds it's going to increase a little bit and get a little bit more difficult. Now we don't need to have an update method in here, so we're just going to go and delete that one. But instead, we're actually going to have a IE numerator that is going to, every couple of certain amount of time, which is actually going to be 2 seconds now, spawn in a new enemy. So we're going to create one here. And this one is going to be called something like spawn next enemy. Now, the first thing we, of course, need to do here is we need to tell it which spawn location we want to spawn this enemy at. So we're going to create a random range of numbers depending on how many spawn points we have inside our array. So what I can do in here is I can actually go ahead and say I want to create an integer. And this one is going to be called next spawn location. And this one is going to be equal to a random range, parentheses, and then we just need to tell it has to be between 2 numbers. So in this case, it's going to be 0, because we always start counting as 0 when it comes to arrays. And then I want to grab the length of my array. So I'm going to take spawn points dot length. This is actually going to tell us how many indexes are inside this array here. So in this case, it's going to be 8. Actually, it's going to be 7 because we count 0 as well. So with this number here, it's now going to give us just a random number between 0 and 7, which means that we're going to get a random spawn location. So we just need to instantiate the enemy that we have up here. So we're going to say instantiate, and we want to instantiate the enemy, which is the game object that we want to actually grab here. Then I want to tell it where we want it to spawn at. So we're going to say we want it to spawn at spawn points, which is going to be the number that we got up here, because that is the random spawn point, or the index of the random spawn point, dot transform, dot position. And then we just need to tell it that we want it to be rotated at a normal axis. So we're just going to say quaternion dot identity. Next thing, I want to actually take a break. So we're going to wait until the next spawn happens. So we're going to have to go ahead and just copy paste what we did down here at the bottom. So we're going to get the yield return new wait for seconds. We're going to paste that in below here. And this time we actually want to wait with the spawn timer. So instead of actually pasting in a number here, we're just going to say spawn timer. And then we just need to do a check to see if the game is game over, because if we have a game over, we don't want to continue spawning in enemies, of course. So we want to say that if underscore game manager dot underscore game over is equal to false. So we want to check if we're not game over yet. And then I just simply want to start this coroutine one more time. So we're going to say start coroutine, and we can actually do that inside a coroutine, which is kind of funny. We're starting the same coroutine again from within itself. So we're just going to reference to spawn next enemy. So this is just kind of like looping and spawning the next enemy constantly, which is kind of funny to see. So now I'm going to copy this entire thing and paste it below because we're almost done here. And we're going to say that we want to spawn rate increase this time around. So we're going to say spawn rate increase because we need to make it spawn faster and faster to make the game a little bit more difficult each time. I'm just going to delete everything that we have in here. I'm going to copy the yield return new wait for seconds because we do actually need to have that in here. And I'm just going to say that I want to run this one every spawn rate increase, which is 5 currently. And basically what this one is just going to do is that it's going to change the spawn timer number that we have up here by a certain amount. So if this spawn timer decreases, it means that this coroutine here is actually going to start popping out enemies faster, right? Because we're actually checking for the spawn timer in here. So I'm going to go down here and say that underneath the yield return, I want to run an if statement. And I'm just simply going to check if the spawn timer is now greater than or equal to a certain number, so 0.5f. The reason we're doing this is because we do actually want to not have it spawn faster after a certain point, because we can actually end up going into the negative at some point, which is not really a good thing. So we don't want to keep decreasing the spawn timer until we hit a negative, because then it's going to start like popping out 1,000 enemies on the screen at the same time, because it's trying to spawn enemies at a negative rate, which is going to break your game and crash your computer. So we need to make sure we actually stop it at some point. So if the spawn timer gets to 0.5, then we don't want to keep increasing the spawn rate. Okay, so this is just kind of like a check to make sure the game doesn't break. However, if the number is above 0.5, then we can still go ahead and decrease the spawn timer. So what I'm going to do is I'm going to say that the spawn timer is going to be minus equal to 0.2. And again, you can just kind of like increase or decrease this number depending on how much you want this to, like how fast you want the enemies to spawn in faster. I'm just going to do it like slowly, gradually over time. So I'm just doing a tiny bit every single 5 seconds. So with this one, we can actually go ahead and say that we just need to do the same thing as we did up here. We want to start the coroutine. I'm going to put it in here. And instead, we're just going to say we want to start the same coroutine that we're inside of right now. So now the last thing we just need to do before we're actually done with this game is to go back up inside our start method and actually run these coroutines. So we're going to say start coroutine, just going to run the spawn next enemy. Then I'm going to duplicate this and say I want to run the spawn rate increase, because we have to run them at least once for these to keep looping again. So with this saved, we can now go back inside our game. We can actually play the game, and now it should actually be working. So it's going to spawn in an enemy. Oh, it's following me, so I'm going to shoot it. Oh, another one spawned in, because it's spawning in enemies. And slowly over time, it's going to increase the spawn rate of enemies. And you can always make this smaller or bigger. So if you want to zoom out the camera a little bit so it's not, big like it is here, you can always go back inside your main camera. And you can just say that you want to increase the size. So we have something like, let's say 6 instead. And then you can always move the spawn points out. So I just went ahead and increased a little bit here. So we actually have the spawn points a little further out. So what I can do now is we actually have a smaller game. So it's a little bit more like, top down and not as zoomed out. This looks a lot better, I think. So we can actually shoot these. We don't have any sort of counter. We could technically just like every single time we kill an enemy, make it count inside the console how many we killed. I'll let you guys figure that out as homework, how to do that, because it's actually pretty simple to do. But yeah, essentially we now have a game. And of course, once you have the counter working, you would build a UI there might be like counting the enemies that you've killed on top of the screen here, so you can actually see them. I do have a UI tutorial that you can also follow, so you can actually go ahead and look that up if you want to. But with this, we now have a working game. Oh, we're actually losing here. So I hope this was kind of fun for you guys to create together with me. A couple of hiccups along the way, but I think we did okay. Essentially, what these kind of game projects are supposed to do is just kind of like show you how games can be created and what the thought process are when it goes into it. Because a lot of times when you start out making games inside Unity, it can be kind of overwhelming. You can't see like, you kind of see it as there being like 1,000 puzzle pieces and how do these all go together? But you just take it one step at a time. You just focus on the player. Once you get the player working, then then you maybe create an enemy, and then you start creating the AI for the enemy so it actually follows the player. So you just take it one step at a time, and until we reach a certain point, and then at some point you just kind of have a game working like we have here. So with that said, I hope you enjoyed, and I hope to see you guys next time.